For most of human history, nobody had seen an atom. No microscope existed. No laboratory could detect invisible particles. And yet, more than 2,000 years ago, one man imagined them anyway. That man was Democritus. While most people believed everything was made from earth, fire, air, and water, Democritus proposed something radical. He believed every object in the universe was built from tiny, indivisible pieces moving through empty space. He called them atomos, meaning uncuttable. It sounded absurd. After all, how could someone claim invisible particles existed without seeing them? But Democritus followed pure logic. If you keep cutting a rock into smaller and smaller pieces, eventually something must remain. Something too small to divide further. That idea became the first version of the atom. But there was a problem. Philosophy is not proof. Democritus had no experiments, no measurements, no evidence. And another philosopher, Aristotle, completely rejected the idea. Aristotle believed matter was continuous, not made of tiny particles. Since Aristotle became incredibly influential, the atomic idea slowly disappeared for centuries. Humanity stopped asking whether matter was built from invisible pieces. Then something changed. Scientists began testing nature instead of simply thinking about it. Careful measurements replaced assumptions. Strange chemical reactions revealed patterns nobody could explain. Substances combined in fixed amounts again and again with perfect consistency. It was as if matter followed hidden rules beneath the surface. And slowly, the forgotten idea of atoms began returning from the shadows. In a strange way, the atom was born twice, first as a philosophical guess, then as a scientific mystery waiting to be solved. Nobody yet understood what atoms looked like, how many existed, or whether they even contained smaller parts inside them, but the question had returned. And this time, humanity had tools powerful enough to investigate reality directly instead of imagining it from a distance. The next discoveries would completely transform humanity's understanding of matter forever itself. For centuries, atoms remained nothing more than an interesting idea. Nobody knew whether they truly existed. Then chemistry changed everything. In the early 19th century, John Dalton noticed something strange. Elements always combined in fixed ratios. Water was never random. It always contained the same proportions of hydrogen and oxygen. Dalton realized matter behaved as if it were built from tiny building blocks that could combine only in specific ways. Suddenly, atoms were no longer philosophy. They became science. But Dalton imagined atoms as solid, indivisible spheres, simple, complete, or so it seemed. Then came J.J. Thomson. Using experiments with electricity, he discovered electrons, tiny negatively charged particles hidden inside atoms. That discovery shattered Dalton's model completely. Atoms were divisible after all. Thomson proposed the plum pudding model, where electrons floated inside positive matter like raisins inside a cake. Then another surprise arrived. Ernest Rutherford fired radioactive particles at thin gold foil, expecting them to pass through easily. Most did, but some bounced backward. It made no sense. Rutherford realized atoms were mostly empty space, with a tiny, dense nucleus at the center. The old model collapsed instantly. Next came Niels Bohr. He suggested electrons moved around the nucleus in fixed energy levels, almost like planets orbiting the Sunday. For the first time, scientists could explain why atoms emitted specific colors of light. The model worked beautifully, yet another problem appeared. Electrons did not behave like normal objects. Sometimes they acted like particles, other times they behaved like waves. The deeper scientists looked, the stranger the atom became. Every new discovery solved one mystery while creating another. What began as a simple invisible particle was transforming into something far more complicated than anyone imagined. Humanity thought it was uncovering the structure of matter. Instead, it was uncovering the limits of human intuition itself. Each model felt final at first. Scientists believed they had uncovered the true structure of matter, yet every experiment exposed cracks in the previous explanation. The atom kept refusing simplicity. Instead of becoming clearer, it became more mysterious. By the beginning of the 20th century, physicists faced truth. Classical physics could no longer explain atomic behavior. By the early 20th century, physics was breaking apart. The atom no longer behaved like a tiny solar system. Electrons refused to follow predictable paths. Light behaved like both a wave and a particle. The deeper scientists investigated matter, the stranger reality became. Then quantum physics arrived and completely changed humanity's understanding of the universe. Albert Einstein showed that light itself came in tiny packets of energy called quanta. Soon after, Werner Heisenberg discovered something shocking. You cannot know both the exact position and momentum of an electron at the same time. The more precisely you measure one, the less certain the other becomes. This was not a problem with technology. It appeared to be a fundamental rule of nature itself. Then Erwin Schrödinger introduced an even stranger idea. Electrons were not tiny balls orbiting the nucleus. They behaved more like probability waves spread across space. Instead of existing in one exact location, an electron existed as many possible outcomes until measured. Reality at atomic scales was no longer fixed and predictable. It became uncertain and deeply mysterious. Everything people thought they understood about matter suddenly collapsed. Atoms were not miniature machines following simple rules. They were quantum systems filled with probabilities, uncertainty, and invisible interactions. Even empty space was not truly empty anymore. Particles could briefly appear and disappear constantly inside the quantum world. And yet, despite how strange quantum physics sounds, it works with astonishing accuracy. Modern technology depends on it. Smartphones, lasers, computers, and semiconductors all exist because scientists learned how quantum behavior controls atoms. What began with Democritus imagining invisible particles eventually transformed into one of the deepest scientific revolutions in history. The atom was never just a tiny object. It became a doorway into a reality far stranger than human intuition ever expected. The more humanity discovered about matter, the clearer one truth became. Nature is not only stranger than ancient philosophers imagined, it may be stranger than the human mind can ever fully comprehend itself completely.